Yes. Yes, so here we are, ready for the next keynote talk. And I'm very happy to welcome Professor Federico Corni from the University of Bolzano. Federico Corni is a professor of didactics of physics at the Faculty of Education of this university in Italy. His main research interest concerns the development of an innovative physics course and materials for kindergarten and primary school teacher education based upon an imaginative, metaphoric, and narrative approach to the natural and technical world, with interdisciplinary contributions from the other sciences and the humanities. He is the scientific head of Fisica in Moto, Industrial Educational Lab Educati Factory in Bologna. He is co-leader together with Stamatis Foco of the GIREP thematic group Physics Preparation of Teachers in Grade 6, K6, and also responsible for several local and international projects. So the next thing is to give you the mic, Professor Federico Corni. Thank you.
Thank you, John, for introducing me, and thank you for inviting me to this very interesting GIREP webinar. I attended the 2020 webinar seminar and was already very interesting, that one, but I think that this is the step forward again. So let me show my slides. Do you see them?
Yes, we can.
Okay, thank you. So the title of my talk is The Role of Metaphors in Primary Teacher Education in Physics. And I would start my presentation by reading the first statement of this George Lakoff paper of 2014, the discovery of conceptual metaphor independently by Reddy and myself and George Lakoff in the late 70s showed that metaphor is primarily conceptual and secondarily linguistic, gestural, and visual. This is a theoretical base for a teacher education in physics based on conceptual metaphors. So this, do you see also this overprint? So, okay, this is better.
Yes.
The outline of my talk, I will start trying to introduce with an answer to this question, why metaphors in teacher education in physics. Then I will divide my talk in two parts. First, I will introduce conceptual metaphor theory for who of you that are not familiar with, and will present some example of conceptual metaphors in teacher education in physics. Then I will end with a summary concerning learning and skills that we expect from student teachers. So, why metaphors in teacher education in physics? A traditional physics course and even courses based upon recent advances in the application of cognitive science to physics education do not suit the needs and motivation of student teacher at kindergarten and primary school levels. These teachers need to learn science and physics in an elementary but foundational and scientifically rigorous way. They need to consider physics as relevant for their future work and feel able themselves to translate their learning into everyday didactic practice. So student teachers should be exposed to experiencing natural and technical processes leading to a form of primary physical science in a way that parallels that of the children they would be charged to educate, relies on the elementary conceptualization basic to human thought, from children to adults, from common people to scientists, and is respectful of their humanities background, because we have to remember that our teacher students are fundamental humanists. So how a primary physics education of teacher can be realized? What is a possible theoretical foundation? If we assume, starting from the quotation I gave from George Lakoff, from cognitive science, that human mind works imaginatively, uses metaphors to conceptualize, then conceptual metaphor theory can be a powerful approach for primary school teacher education in physics. So let's introduce conceptual metaphor theory. I met this theory in 2013 at a conference in Turkey when Tamer Amin, Frederick Jepson, and Jasper Haglund organized a symposium titled Conceptual Metaphor and Embodied Cognition in Science Learning. After that very interesting symposium, a special issue of the Journal of Science Education followed with the main contribution of the participants. That symposium worked on results on neuroscience, cognitive psychology, and cognitive linguistics, like that mental imagery relies on the same brain mechanisms used for perception and action, that the multi-component working memory system includes a component that stores visuospatial information to be used to carry out cognitive tasks, and that abstract concepts are understood in terms of generalization over sensory motor experiences like image schemas via metaphorical mapping. The last sentence is the theoretical base for a possible education in physics of student teacher, and it is the base of the conceptual metaphor theory. Conceptual metaphor theory was originally developed by Lakoff and Johnson in the last century. They argued that our conceptual system develops through personal, physical experiences as we interact with the surrounding world. At the most basic level, we form image schemas, knowledge gestalts that emerge out of repeated and patterned sensory motor experience when interacting with the surrounding world. In short, an image schema is a condensed description of perceptual experience for the purpose of mapping spatial structure onto conceptual structure. So we use something that our mind develops from our sensory motor interaction with the world as an abstraction to understand other kinds of concept, maybe more abstract. Image schemas are available to everyone from the earliest years of life. So how does a conceptual metaphor consist? A conceptual metaphor is a figurative comparison in which one idea or conceptual domain, the target domain, is maybe partially understood in terms of another domain that is called the source domain. For example, if we say temperature is a vertical scale, we project vertical scale that comes to our mind as an abstraction from our body. We stand normally vertical, so this is an embodied abstraction, and we project this abstraction onto temperature, and so we realize the concept that temperature is an intensity, that is something that grows up and falls down. The source domain is a non-concrete and embodied domain, but used as an abstraction. This is important because when we say that temperature is a vertical scale, we are not thinking actually to a ladder, but we are abstracting the notion of vertical scale. Examples of image schemas are summarized in this In this table, we see container schema. With these, we see path schema, the substance schema, the important schema that we use to give existence to our abstract concepts. Lakoff and Johnson suggested that these image schemas ground our understanding of abstract concepts and our use of language. One of their central claims is that image schemas may be mapped metaphorically to more abstract domain, forming conceptual metaphors. So we are thinking that this kind of abstraction also ground our knowledge of nature, so physics. In physics, we say, for example, temperature is falling, again using the verticality image schema, that body loses heat, using the container schema for the body and the substance schema for heat, and that electricity flows through the wires, applying the source path goal schema for wires and substance for electric charge. Research in psycholinguistics, neuroscience, and gesture analysis has provided further evidence of the psychological reality of the role of image schemas. Examples of conceptual metaphors often cited are time is money. So we see you waste money, we waste time, sorry. I spent a lot of time with you, earning time, saving time, or that, for example, life is a journey. We are at a crossroad and have to decide which direction is better for our future, for example. Or ideas are food, argument is a war, purposes are desired object, and so on. Actually, we are not interested in this kind of conceptual metaphors for our theme today, because money, journey, food, war, desired object are a little bit large context and are very tightly connected to culture. So they are not universal and they are not at the reach of children. Our focus is on primary metaphors, those that employ image schemas as the known domain. So conceptual metaphors are not exhaustive, of course, because they highlight aspects of a concept, not the entire concepts. We need many metaphors. For example, in the case of energy, to understand the whole concept of energy. Many abstract concepts are too complex to be described by a single metaphor. Various metaphors are needed to illustrate complementary aspects of the concept. I like this image given by Lancor in a seminar in Reggio Emilia, using the traditional Indian story where several blind men are touching an elephant. Each man feels a different part of the elephant, and so I have a different understanding, a different metaphor for the elephant. But the elephant is the sum of their images, is not the single image. For example, the concept of energy is like an elephant. We may be invoking different conceptual metaphors to describe the whole concept. So, if image schemas are abstraction available to everyone, from children to adults, from lay person to scientists, and also so to student teacher, conceptual metaphor theory can be a powerful approach for teacher education in primary physics. I remember an interesting statement by Tamer Amin in Reggio Emilia in 2014. The good news is that the multiple components that make up concepts can be seen as resources readily available to the learner. But the bad news is that it becomes clear that learning a concept involves the challenging task of coordinating multiple knowledge elements. So the focus is displaced on coordinating multiple metaphors used for a single topic, because the single abstraction are already at the reach of the learner, of the pupil or the students. So let me show you an example concerning the concept of energy. I refer to this paper by Rachel Lancor in 2014, using metaphor theory to examine conception of energy in biology, chemistry, and physics. The paper demonstrates that the metaphors and analogy used in textbook and science education literature reveal fundamentally metaphors. And the metaphor they use are, for energy, are the substance metaphor translated into different facets, substance that can be accounted for, that can change form, that can be carried, that can flow, that can be a product or an ingredient of a reaction. The conclusion of the paper is that many of these conceptual metaphors are commonly cited as alternative conception or fallacies students have about energy. But it is probably more accurate to say that students holding this idea have an incomplete understanding of energy, not a wrong understanding of energy. Energy is a conglomerate of the idea listed above. None of these is entirely correct. Taken as a whole, they form a set of coherent conceptual metaphors for energy. From a didactic point of view, teacher can work backwards. By analyzing the metaphors used to communicate, they gain insight into pupils' conceptual metaphors, and therefore can better understand how they conceptualize energy as it applies in a given context. Another paper, again on energy, has been written in 2009 by Tamer Amin. The paper is Conceptual Metaphors Meets Conceptual Change, and in his large research found additional metaphors other than substance metaphor, like more is up, less is down, energy as an object moving on a vertical scale, and object event structure and local event structure. I will not describe for problem of time, but I will just give him his finding. He worked on 200 sentences taken randomly from the British Natural Corpus containing energy, and 150 sentences taken from the Feynman lecture in physics, and compared the metaphors therein. Note that Feynman, in the very same text in which he insists on the abstract nature of concepts, he recruits conceptual metaphor to make sense of it, especially the substance one. Then Turner concludes that he finds that many of these construals in both lay and scientific usage are metaphorical and grounded in experiential knowledge gestalts. Moreover, he finds substantial overlap among the two sets of construals, and when viewed from a conceptual metaphor perspective, this overlap, together with the experiential nature of construals that seem to ground much of scientific understanding of the concept, motivates hypotheses regarding the nature of the continuity between lay and scientific understanding of energy. The second example of conceptual metaphor theory is on physical or continuum physics. From a pure formal perspective, the structure of continuum physics contains fundamental or primitive quantities, laws of balance of these fluid-like quantities, constitutive relation, and the energy principle. These are, of course, the fundamentals and primitives of continuum physics: fluids, heat, electricity, substances, linear motion, rotational motion. We are not dealing about quantum mechanics at all. Every primitive admits a fluid-like quantity, the extensive aspect, and an associated vertical potential, the intensive quantity. A fluid-like quantity in this slide and in my slides, you will notice that I use small caps. Small caps identify metaphors. A fluid-like quantity can be thought of as residing in a space, as in a container, being able to flow down the gradient of its own potential, or being transported by a fluid, or possibly being transported by radiation. Some of these quantities are conserved and some are not. But if we look at the equation of balance for these fluid-like quantities in continuum physics, we can see, of course, we see the analogy between this equation of balance. But the analogy is given by the fact that, for example, the change over time of density can be thought of using the image of storage, the image schema of storage. The conduction and convection current, the image of flow, and the creation of transport through radiation, the idea of production of substance. So if we put these three images into one, if we combine them into one image, we have the image schema of quantities in continuum physics. Again, if we are careful on the subject, we can point out that we are in front of metaphors, of images. If we continue with continuum physics, we would also find other kind of metaphors, but it is not the time to do this now. I would like to proceed toward the second part of my talk, conceptual metaphor in teacher education in physics. So I have listed some points relevant for a curriculum based on metaphor. First, we have to introduce student-teacher to embodied mind and conceptual metaphor theories. Then present them the main image schemas involved in physics, like fluid-like, substance, verticality, force, container, path, obstacle, those we have listed before. Give them several occasions in different contexts to challenge their metaphors so as they become confident of their figure of thought. Help them in differentiating the metaphors in their language and mind. Remember the warning of Tamaramin. We are not, it is not a matter of concepts, of metaphors, because the metaphors are already in our mind. It is a matter of differentiating this or coordinating these small concepts given by metaphors. Support students in analogical thinking, because analogical thinking is supported by metaphorical thinking, and support students when they feel the need for a step toward formal language using icons, maps, modeling, and finally also maths. I will give you two examples concerning conceptual metaphor in teacher education in physics. First is the primary physical science course taught at the University of Bolzano. Here are the two papers that describe this course. The first paper summarized the foundation of the course, and the second paper, the implementation, the evaluation of the course. It is a novel primary physics course for student-teacher at kindergarten and primary school levels that uses cognitive tools such as metaphors. Central to the course is the notion of force of nature, a pictorial idea that could be the idea of elements, no? The natural elements, water, wind, fire, ice, electricity, and so on, that are perceptual gestalts with aspects of quantity that is conceptualized through the fluid-like substance metaphor, intensity with vertical scale, and power with the force metaphor. That in microscopic physics are those topics I listed before. The course identifies imaginative forms of physical science and explicitly makes them available to student teacher as keyword for interpreting phenomena. Actually, these images are already present in any course of any kind, but we, in this case, explicitly make them available to student teacher. The course follows a bottom-up approach where concepts grow on the common figures of mind instead of a top-down approach starting from the formalized science. This is a table that summarizes the content in terms of time allotted to the subject. The course is a 60-hour course, and if you can see, we use 17 hours at the beginning and at the end to introduce philosophical foundation, the embodied mind, the theory of metaphors, and after treating the physics topics using these metaphors, we treat with students how these metaphors can be used and carefully and correctly used in natural language, and how, for example, they can build stories for their children. In the laboratory activities, they directly experience wind and light and try to describe their using quantity, intensity, and power images. They search for linguistic expression in a lab about a force of nature at their chance and try to categorize the metaphors therein, a sort of linguistic exercise to find out metaphors in natural language. And then they do experiments of observation, data acquisition, interpretation, modeling of hydraulic, thermal, and electric processes. And finally, they design a teacher guide. These are the 3 experiments that they do. And in the experiment, they naturally explain the behavior in terms of those basic metaphors and use stock and flow modeling. You can see in the bottom that explicitly show the analogy between the 3 experiments, and the group of this symbol show the single image schema. Energy is introduced using the visual metaphor of substance, mainly using the metaphor of substance, and energy is made available in a system when the potential of a force falls down and is absorbed when another force has the potential that rises up. These are paper. Just to give you some numbers, some results in terms of disciplinary learning. In a questionnaire, students had to answer what are the main characteristics of energy. And every student lists several characteristics on average 3.7 characteristics that have been grouped in this table. The main characteristics of energy, transfer, storage, conservation, transport, and loss by heat are present in high percentages, and at least 2 of them are reported by each student. At the beginning of 2020, 24 in-service teacher, former students, answered a questionnaire about the effectiveness of the course for them. For example, they answered, how do you feel about science and science and teaching? And the great majority of teachers, 86%, feel confident and or autonomous in teaching science. Our second question was, to what extent and in what way do you feel helped by the approach taken at the university course? And almost all teachers declare that they adopt the approach of the course in their own teaching. In some cases, they explicitly express great satisfaction and that the course shaped their teaching. A third question, which elements of the course have shaped your teaching in the most profound ways? And the most frequent course feature teachers have become aware of as important for their teaching are the use of stories, metaphors, and analogies. Again, there's 36% of teachers say that the course provides them with an interesting point of view for the various disciplines and activities in their teaching, not only in science. The second example I would like to give you, yes, I am on time, is about teaching electric circuits, an experimentation developed at the University of Udine with Marisa. We know that electricity is a highly abstract topic, and so metaphoric language cannot be avoided. So, but there is no consensus about which metaphors on electric circuits are appropriate to be taught and in which order they should be taught. So we, aware that metaphors highlight aspects and not the whole concepts in a subject, we decided not to study which metaphor are better than other, but we wanted to study to what extent metaphor is learned by student teacher, how they critically use it, and what is their attitude toward it. The intervention involved 120 student teachers of the third year of the master degree in education at Udine. First, we gave them 2-hour seminar during the semester in which I introduced embodied cognition, conceptual metaphor theory, and gave them typical image schemas used in physics. Then lecture on electricity and electric circuits were taught with conventional approach. And finally, students had to fill in a questionnaire consisting of open-ended questions. Among the answers of the students to this question, we selected some answers. Some of them were correct, scientifically correct. Some of them were scientifically wrong, and gave back to the students, asking them to do a sort of metaphorical study, analysis of this answer. They have to evidence the metaphors behind those answers, to suitably reformulate the expression on the basis of their analysis, and motivate their choices. Moreover, students have had to leave a comment in reaction to the whole activity. I will show you just two of these answers. One answer was to the question, I insert a switch in a battery bulb circuit. I make myself small and enter the copper wire of the circuit. What I see when the switch is open. The question we selected is, the answer we selected is, if the switch is open, I can see the electrons stopping. They can no longer flow. The analysis of the students of this answer has been analyzed and grouped, and 88% of students detected the fluid-like and the numerable substance metaphor. The fluid-like metaphors comes from the term no longer flow, and the numerable substance metaphors comes from the electron stopping, that electrons are small particles that we could even number. Only 12% of students detect only one of the two. The interesting thing is that 71% of students correctly rephrase the statement using only one of the two metaphors, and 83% explicitly pointed out that only one metaphor should be better used in the same statement from a didactical point of view. Another question and answer we used is that one, what do I see in the connecting wires when the switch is closed? And we've selected a wrong a scientifically wrong answer. The current intensity passes through the whole circuit. 83% of students detect the vertical level intensity metaphor, the intensity passes, and 33% of students detected also the fluidized substance and the path cycle metaphor that are secondary metaphors in this case. And the interesting point is that 96% of students correctly rephrase the statement, and 100% of students correctly motivate their formulation, showing that they have correctly differentiated the intensive aspect of electricity and the extensive aspect of electricity that are, one is conceptualized by verticality image schema, and the other one with the substance-like schema. Some comments of the students. I read only the second one. As future teacher, conceptual metaphor is useful in order to learn to look at things with the eyes of our pupils. By being able to understand their structure and the way they interpret concepts, it is easier to understand how to fill in the gaps. So, summary, in terms of learning expected and also found in some experimentation. Metaphor is an approach to physics education suitable for primary teacher because it allows an elementary understanding of the fundamental concepts of the discipline. It offers some few schemas transversal to the discipline, and not only to the discipline, but also to the other discipline they have to taught in their profession. It supports analogical thinking. It values the humanities background of teacher. It relies on natural language, and teachers are able to interpret and to hear verbal, gestural, and graphic language of their pupils. And it is the base for development of the scientific formal language. In terms of skills expected in teacher, and again found in the experimentation, teachers become able to speak naturally about nature, but scientifically correct. They can coherently use different kinds of language because they see the metaphor behind. They become sensitive to pupil metaphors. They learn to listen to their pupils. This is a sentence that I have found very often. The student teacher declare that they are able now to listen someone else speaking. They become able to see obstacles and progress in their pupils, and they are favored in evaluating the pupils' learning. So thank you for your attention. And if you like, this is a list of possible literature. Where are we?
Yes.
I get lost. Okay. Yeah, concluded. Sorry, I can't find the webinar. Where is it? Okay.
Yes.
Now see it.
I
Okay.
stopped the screen sharing for you.
Okay. Thank
Yes,
you.
thank you very much, Professor Corney, for your very interesting talk. I'm really enthused, a lot enthused when I hear of this cognitive interpretation, and this is what your talk was all about. Cognitive interpretation of the world around us, something that we have to convey to the students, and that the teachers must know it to be able to convey it. That's what I hope, at least. And leading also to the evolution of ideas, starting from the very basic and then going on to more complex ideas. So thank you very much for that. First, we shall see whether there are any people who would like to ask you any questions. Is there anybody who would like to ask a question, please?
For any question, you can raise your hand or you can simply write in the chat.
Yes. No? Nobody has written in the chat and nobody has raised his hand. Or is there somebody? Yes, somebody has raised his hand. Hector, James, Parades. Yes, please.
Yes, hello. Can you hear me?
Yes.
Thank you. And Dr. Corney, very interesting your presentation. I just want to ask you, is there any study or any research about, okay, metaphors can help us to transfer knowledge to students in a more natural way, or a more familiar way for them. But is there any research about the how inefficient can be this knowledge transfer, or which would be the disadvantage of using metaphors or analogies when teaching physical concepts? Is there any research about this topic? The disadvantages, not exactly the advantages of using metaphors or analogies, but disadvantages of using them for getting a better or more precise physical concept. Thank you.
To my knowledge, there are several papers on using metaphors with children or with student teacher. I think that the main point origin of misconception or wrong use of metaphors is due to the fact that the metaphors are used literally. I emphasize the fact that image schemas in cognitive linguistics and embodied mind theory, image schemas are used as abstraction. So the teacher has to be aware that using this kind of images, image schemas, he or she is using an abstraction. I think that this is the main origin of possible misunderstanding in the use of this kind of approach, I would say. But if you like, I could give you some papers about this. As I told in my talk, you have to spend some time to introduce student teacher to this kind of philosophy, this kind of approach to language and to cognition. Because if you don't spend this time, students could be led to use these kind of images like substance, like vertical scale, as concrete things.
Thank you very much.
You're welcome.
Yes, I think Marisa Michalina, Professor Michalina has a question.
Is not yet a question. It's just to continue such a sort of discussion about the value and the risk on metaphors. As Federico knows, I was the main against person to the metaphor and his approach. He knows that we fight a lot about that because my approach to primary physics education is looking to the concept as the higher level we can reach, looking to physics as it is and without using different paths. But he was very good in a strategy to put me in difficulties because he invited this woman from the US, I don't remember the name, can you explain, Federico? and he invited me and her to speak about metaphors or not metaphors and energy. And I was sustaining my approach of energy, which is also published with Paul Aheron and other people in literature, which is absolutely against the use of metaphors. But during the discussion, it was very interesting because all my quoted difficulties in learning and misconception and way of misunderstanding of the concept are quoted as metaphors by the other speakers. And then I try to work with my student, put in evidence that each difficulties or spontaneous ideas far from physics 1 are originated by metaphors, and the awareness of such a sort of kind of metaphor inside helps them to overcome conceptual knots and to be aware of the conceptual knots. So, as far as I know, I will not teach using metaphor, as Federico knows, but I want to teach, as in the experiment we have done, I want to teach with a physics approach, just the way in which I'm looking to, with the framework of Reiner's Tweet, conceptual reconstruction of the meaning that we are treating. But if we look at the metaphor as possible approach and the way in which we can find in the common sense the way in which people is speaking about the different concepts, we gain in teacher education a lot of awareness of what is right and what is wrong. This is proved by activities. So the point that I wanted to appreciate in your talk, Federico, and sorry for doing that, is just the big focus on how metaphors are spontaneous, are born in any case. And if you don't explicit and you don't treat them, you cannot be aware and able to overcome. And in the same way, I forgot to say what I should say. The same way is not a transmitted structured teaching that can give awareness of the concept. The continuous passage from common sense to physics point of view have to be, in my experience, have to be followed also in teacher education. It's very important. So I believe it's very important, this aspect. But Federico says, and I agree a lot, we have not to teach through metaphors. We have to use metaphors to support teaching of materials. This is a very delicate difference.
There is a chat who asks for experience in mathematical education. I know that there is a very interesting book that is Where Mathematics Come From by Lakoff and Nunez that I suggest Claudio Fascio, I think, to read it, because it is very interesting, because the Lakoff and Nunez tried to find the metaphorical structure of mathematics. That is a very abstract concept, very abstract construals of our mind. I met Nunez in a conference in Bologna some times ago and asked himself if he knew about experimentation of this kind of approach. And he answered me that that book remained also a theory. So in mathematics education, at least to my knowledge, there is no experience of application of metaphors at present.
In the chat is written, did you experiment this approach directly with children?
Yes, directly with children, not direct, not me, no, yes, me directly, but especially through my students that asked me for a thesis. I have 45 or 50 students, master students, in master thesis with me, and they their thesis, there was all experimental thesis. They tried to design a path for their kids using the learning they had in the course, and they actually experienced that. I also have reported in one of the two papers I showed you, published on interchange, sorry. I also reported there the results of an experimentation of a thesis of a student. If you like, you can see it with very interesting results concerning the learning of the concept of heat, of the difference between heat and temperature for kindergarten pupils.
If I may ask a question, may I, Anthony?
Yes, yes.
You are the boss.
No, because you have mentioned schemas, preconceptions, which are not necessarily the scientific views, right? They can be, but they needn't be. How then do we connect these metaphors with mental models? Because also in mental models, we talk of preconceptions, and there are these ideas in our heads that we speak about. Are the metaphors things that we talk about, and the mental models things we imagine and think about? What is the link? Maybe.
No, it is difficult. It is a difficult answer because we should agree what is a mental model, what is a metaphor, and so on. So it is not so simple to answer. But I just remember the statement I read at the beginning of my talk. Metaphor is primarily conceptual and secondarily in language and in gesture. So I think that mental model and metaphors are very akin, very close together.
Very close. Yes.
I would say that a mental model is a complex of small metaphors, but I'm not sure.
I think we should meet to discuss this a little bit more, maybe.
Yeah.
Yes. So we thank you very much, Professor Corney, for a very interesting talk, as I said before. I do not know whether Anthony would like to say anything else, or perhaps Professor Michelini, to end this day, the first day of the webinar.
Yes, my only comment, thanks, Joan, thanks also Federico. My only comment is that for tomorrow, you will be receiving an update email with the links for the work group meetings. That's an email I will send directly. And also 1 hour before the start of the webinar, you will receive also a link, like an update from Zoom with the link for the webinar, for the plenary. So tomorrow, I'll see you all at 3 p.m. Malta time at the webinar. Important. The webinar, not the work group meetings, like we did today. That's all from my end.
Excuse me, but there is a chat where it says, if you can share the references, please, it would be fantastic. So perhaps...
how can I share them? I could send you the slides. No.
You
No,
can
there
send
are
them
no-
to us if you want, and we can
Perhaps
put them
that's the best
available,
way.
yeah, on the website.
Okay, I'll send to you too, Anthony.
Yes,
Yes,
and we can
please.
link them to your talk.
Okay.
Yes. Anywhere where we expected to send the answers to the questions. Was this? I don't understand this. Anywhere where we are expected to send the answers to the
Because
questions.
there is
Link to the group
a
question.
comment by
Ah,
Russell.
yes, this is Russell. Maybe this was in the group 3, which was your group, Marisa, the quantum mechanics group, because I was there when you were asking, and I know that Russell was there also. Where do they send the answers to the questions, Marisa? Thank you, Federico.
I don't ask to send nothing, but to write only.
Okay.
So tomorrow they will be ready to discuss.
Okay.
If I have time, I can prepare a form for the answer to the questions, but I'm not sure because I have many points to treat now, so I will see. If I will prepare a form, I will send you, and you can send to everybody.
I just wrote on the chat for them to answer your questions, and then they can discuss within the group, no?
Yes, of course.
That's the important thing. that
We
they
have
have-
already sent the questions
Yes.
by means of a letter in advance, and now we have only to recall,
Mhm.
to remember.
Okay, so I think that's practically it. If nobody wants to say anything else, and we will meet tomorrow at 3 p.m. Malta time. Thank you very much, everyone.
Thanks. Bye bye. See you tomorrow.
Bye-bye. Thank you.